Hi, I'm Mridul Ganesha, Cartoon December CE 230162. So, I will be presenting the first part of the project, which is the overall project objective. So, we are given a scenario. The scenario is we are a group of engineers who are tasked to maintain the system stability, power system stability, during the integration of renewable energy sources. So, the scenario is we are having a high number of RE penetration to the power energy system. So, we are tasked to design a system to maintain the stability. Okay, so the important part of these projects are the power system modeling, the stability state analysis, the renewable energy integration analysis, the control strategies, and the recommendation improvement. So from the next part, we will be getting into the project. Okay, to solve this scenario, what we're choosing is we are choosing a biomass plant to stabilize the system to work as a base load. So the plant uses the EFP as a fuel. So EFP is the empty food branches from palm oil. So this fuel got few advantages and disadvantages. So it can provide continuous power, and it can reduce dependence on fossil fuel. But it got few challenges too, which are it got high moisture content, and we need to do some pre-treatment before combustion, and we got also transportation and the supply variability issues for this fuel. And we can see the table for the properties of the empty fruit branch, and we can also see the moisture content of the fuel. Thank you. So for the IEE power system standard. So the IE standard that we are using for this is the IE 1547. So this is for the regulating inverters and controller and protection systems. And we go for the last one, which is the power steady state, power system steady state stability analysis. So for this part, we get to understand the definition and the analysis of the system, and the main factor affecting the stability of the grid is the integration of the green energy, the other green energy like solar to the system. That's what affecting the stability. So to improve the system, what we can do is we can do some methods which such as the we can add AVR to regulate the system, and we can add some energy systems to the system, pump hydro batteries, and we can also strengthen the network, and we can add real-time monitoring to and add some as a control strategies to maintain the stability of the system. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Kazaril Afham bin Kamaruzaman. My number matric is CE220112. I would like to present about the methodology for this project. So the methodology for the new housing construction project outlines the precise steps and tasks required for planning and investigation, guaranteeing conformity with the project goals. So at the flowchart that given, the first step was the review existing power system infrastructure. The next one is data collection and analysis, stability assessment, identify stability challenge, designing strategies for stability enhancement, power system modeling and simulation, policy and regulatory recommendation, and the last one was the reporting and documentation. So the bus that be selected is a 12 bus load. So the modification we did at the command window to obtain the voltage value in per unit appears in the figure below. So the bus 12 initial load was the 11.2 megawatt with a 7.5 mega VAR. We measured at the voltage at bus 12 after increasing the load by 100%. Until the system failed, we keep increasing the load by bus 12 by 100% increments. At bus 12 had a load of 179.2 megawatt and 120 mega VAR at the time of collapse, and the voltage had fallen in to 0.880 per unit. So we can see at the table for the load at a real power and reactive power, it keep increasing 100%. 11.2, 22.4, 44.8, 89.6, and the last one is 179.2, and it same goes to reactive power and the voltage PU. So the voltage PU, we can see the voltage per unit it keep decreasing until the last point is 0.880. So the next one is the result of impact of biomass power grid on load flow analysis. The load flow at the bus 12 may be impacted by the biomass power system analysis. In order to help ease the problem, a biomass power plant has been constructed at bus 12. The result determine whether biomass power generation is used and whether the electricity is added to the system. So 100 megawatt is the value that we use. For the 100 megawatt, the voltage per unit is 0.35. So it increasing than the 0.880, and it close to 1 PU. So the system is become normal again. So that's all from me. Thank you.
Next, we move to the discussion part, but first let me introduce myself first. My name is Magdalena Satu Anak Nelson and my metric number is AE210013. So the first point is role of biomass in sustainable energy system. As we know, biomass provide constant and reliability based on load power, and it unique among renewable as it can operate continuously like fossil fuel plant. Second one is power system analysis. As bus 1, as we know as like bus, maintain constant voltage, magnitude and angle. We can see that reactive power output vary due to generator limit, which is bus 9 reaches its maximum reactive power. Next, the impact of biomass plant at bus 12. Bus 12 voltage stabilized at 0.994 pu by improving local voltage profile. Lastly, enhancing power system stability. Hybrid systems such as solar, wind, biomass will increase reliability and energy storage such as battery, pumped hydro and hydrogen will smoothest renewable variability. Last but not least, we move to the conclusion part. Integrating biomass as its base load power source in a modern power grid enhance renewable energy system by providing reliable, continuous power that stabilize the grid and reduce dependence on fossil fuel. Strategic investment in technology and sustainable sourcing are essential to create a resilient, balanced, and cleaner energy in the future. So that's all from us. Thank you.